The periodic table put forth by Mendeleev was quite well defined, but it wasn't the best table. Why? Because with time, the number of elements being discovered increased and fitting them into the table according to the periodic law seemed difficult. Also, we have studied the major limitations of the periodic table by Mendeleev in the previous video. So with all these limitations, how do we study the elements? How do we carry out the periodic classification? Well, if the elements discovered later did not follow the periodic law given by Mendeleev, then what was the way to arrange them? When atomic mass was taken as a fundamental property to classify elements, it resulted in failure. So, what should be the fundamental property to classify elements? In the year 1913, Henry Moseley suggested that atomic number should be the fundamental property to classify elements. Why atomic number? Atomic number of an element is equal to the number of electrons or protons present in the atom of the element. And hence, atomic number of elements are fixed and it increases regularly. It was also observed that when elements were classified on the basis of atomic number, a few anomalies of Mendeleev's periodic classification could be eliminated. Let's just recall three major anomalies of Mendeleev's classification. The first limitation or anomaly was in the position of hydrogen. Position of isotopes and position of certain elements like cobalt and nickel remained as an anomaly in his classification. Now let's check how each of these anomalies could be removed if atomic number is taken as the basis for classification. Now let's check for the position of hydrogen. Hydrogen is an element with one electron, so its atomic number is also 1. In the modern periodic table, elements are arranged in the increasing order of atomic number and not on the basis of atomic mass. So, the group elements will have same number of valence electron and hydrogen with 1 electron has valency 1. Hence, placing it with group 1 elements now became sensible. Position of the isotopes. All the isotopes of an element have the same number of electrons. That means their atomic number is same and their atomic mass is different. Since in the modern periodic table, classification is based on the increasing order of atomic number, so isotopes can be arranged in the same slot as their atomic numbers are same and only the atomic mass is different. So for example, chlorine 35 and 37 with same atomic number 17 can be placed in the same group in the periodic table. The next major limitation of Mendeleev's classification was in positioning certain elements with higher atomic mass before the element with lower atomic mass. Now, cobalt with higher atomic mass was placed before nickel. But let's understand that the atomic number of cobalt is 27 and that of nickel is 28. So, in modern periodic table where elements are going to be arranged in the increasing order of atomic number, cobalt will come before nickel even though its atomic mass is higher. So, coming back to the classification, did Henry Moseley think that characteristics of elements are based on their atomic numbers and not on the basis of atomic mass? Yes, that's what he meant, and with this, there emerged a new law of studying the periodicity of elements. It was called the modern periodic law. It was a modification of the Mendeleev's periodic law. The law states that properties of elements are a periodic function of their atomic number. This means that the physical and chemical properties of elements do occur periodically, but this happens when they are arranged according to their atomic numbers. Designing the periodic table and classification of elements became more easier when atomic number was considered as the fundamental property. This was because when new elements were discovered, there was no difficulty in accommodating them in the table in the increasing order of the atomic number. We know that properties of elements depend on the number of valence electron, that is the outermost electrons in their atom. So when elements were arranged according to the increasing atomic numbers, then the elements having same number of valence electrons occurred at regular intervals. Since the number of valence electrons in the element show periodicity, the chemical properties also show periodicity. Periodicity means repetition of properties. For example, the elements shown here, lithium, sodium, potassium, which come one after the other in a group, have similar properties as their valence electrons are same. So from this we understood that periodicity in the electronic configuration leads to the periodicity in chemical properties. Elements with same valency occur at regular intervals or periods, and hence the electronic configuration, that is the pattern of electronic configuration, is also repeated and the properties are also repeated. So the real significance of this classification is that periodicity in the properties of elements are related to the periodicity in the electronic configuration, and this became an ideal arrangement. With these concepts, the modern periodic table or the long-form periodic table was designed by Niels Bohr. Till date, we are using this periodic table or classification of elements. I hope that you have understood the basis of development of modern periodic table. If you liked this video, hit the like button and share the video among your friends and family. Do show your love and support by subscribing the channel, and check the links for the playlist of Term 2 contents of Physics and Chemistry in the description below.